Okay, so this is surds or square roots, and you'll get these questions on page 238.
Sorry teachers for disturbing class. Third time lucky, can you please
Okay, so the first one there, lads, says express root 108 in the form k root 3. So in other words, what they're saying to you is they want you to break up the square root of 108 into 3 multiplied by some number. So 108 divided by 3 is 36. So 3 by 36 is 108. And the rules of surds then say that I can say that that's root 3 by the root of 36. Root 3 stays the way it is because I want that in the answer. And then I'll just rewrite it as 6 root 3. So k in this instance has a value of 6. Because they could ask you in a question, they could say, instead of saying express it in the form k root 3, they could just say find the value of k. Question 2. If the root of 200 is equal to k root 2, evaluate k. So that's exactly what I'm talking about. So let's look at root 200. So we'll break this down and we'll say it's 10 by 2. No, we won't. That'll be bad. Let's see. 100 by 2. Sorry. Now, some of you said that you would prefer to use brackets. If you prefer to use brackets, well then that's fine. I'm not going to. So you'll understand what I mean when you see the dot. So I'll break that up. That's the root of 100 by the root of 2. And the square root of 100 is 10 root 2. Question 3. Express 3 and 1 over 16, or the root of 3 and 1 over 16 as a fraction in the form a over b, where a and b are an element of n. So they're telling you it's natural number, so it's not going to be a negative fraction, it's going to be a positive fraction. First job, change it. So you'll say change 3 and 1 16, so you can use your calculator into a top heavy fraction. So it's going to be 49 over 16. And then there's a rule in indices that says I can break that up. Similar to the multiplication, I can say, well, it's the root of 49 over the root of 16. 7 over 4. Question 4. Express the root of 48 in the form a root b, and b has to be a prime number. It's worth remembering prime numbers. The first couple of prime numbers would be 2, 3, 5, 7. 9 is not a prime number. It's an odd number, but it's not prime. 11, etc. So most people forget that 2 is prime, and a lot of people often think that 1 is considered a prime number. It's not. So back to my root 48. Well, I'm going to say that, let me see, 2, if I divide 2 into it, see if I can get a nice, so 48 divided by 2 is 24. So I won't pick that, because I can't get the square root of 24 easily. I'll try 3. 48 divided by 3 is 16, and I will use 16 by 3 because I can get the square root of 16 easily. So it'll be the root of 16 by the root of 3, 4 root 3, and the number under the square root is prime, so I've met all the conditions of the question. Sorry, 4b. It says simplify to 4 plus 2 root 3, sorry, 4 minus 2 root 3, minus, all in a bracket, 6 minus the root of 48. Now I'm going to multiply this as I normally would, but hopefully you spot that the root 3 and the root 48, you're going to have to work with that. So 2 by 4 is 8, minus 4 root 3. Notice it's just 2 by 2, is 4, and it's 4 root 3, minus 6 plus the root of 48. 8 minus 6 is 2, and then minus 4 root 3. But we know from part A that the root of 48 can be written as 4 root 3. They will cancel off for me, so my final answer is just 2. I'll put it over there to save a bit of space. Question 5. You've the root of 50 minus the root of 200 plus the root of 98, and you're told that that's equal to k root 2. And you're asked, find the value of k squared. Now, don't worry about the k squared. If you can find k, well then you can just square it. So it's easy to find k squared, so don't panic about it. Get k first of all, and then work for the k squared. This bit over here, the root 2, that tells me that I need to change each of the surds that I've got on the left hand side, that it's something root 2, something root 2, something root 2. So this one here, root 50, that's going to be 25 by 2 minus 100 by 2 plus 49 by 2. So starting to speed up a little bit, that'll be 5 root 2 minus 10 root 2, 7 root 2. Adding those together, 5 and 7 is 13, minus 10 is 3 root 2, and I know that that's equal to k root 2. So that tells me k is equal to 3, and if I know k is equal to 3, well then k squared has to equal to 9. Okay? Keep going. Where are we up to now? Number 6. You've root 3 multiplied by 4 root 3. The root of 27. Root of 75. You're told that's equal to a. Okay, so first thing I'd do is I'd multiply in the root 3 that's on the outside first. And again, I went through this with you yesterday. Sometimes people panic. Just write it down and then look to change it if it needs to be changed. So this is 4 root 3 by root 3 plus root 3 by the root of 27 minus root 3 by the root of 75. Now there's a lot of root 3, so I'm going to see if I can write things having a root 3 in them. This bit here, I left with 4. Root 3 by root 3 is root 3 squared. Of course, the square and the square root cancel just to leave the 3. So it's 4 by 3. I mean, the root 3 by root 27, you could do that in your calculator and it would spit it back out in its simplest term. So it would have a root 3 in it. But just to show you how to do it, root 3, it'll be root 9 by root 3. So 9 by 3 is 27. And then root 25 by root 3, because 25 by 3 is 75. So I'm starting to speed up a little bit with the simplification. Plus root 3 by root 3, so it's 3 root 9. Root 3 by root 3, 3 root 25. One thing at a time. 12 root 3 by root, 3 by root 9, well that gives me 9, 3 3's, minus 3 by 5 minus 15. Adding those together is 21. 6 is what the value of a is. Number 7. You're asked to simplify it. They want it in terms of, or in the form k root 5. Now, I'm not going to do this, but I don't know if you can spot, that's the difference of two squares. So you could use the difference of two squares. We've seen something like this in algebra before as well. That's the difference of two squares. So what I could do, I'm not going to do it out this way for you, but what you could easily say would be 7 plus the root of 5 plus 7 minus the root of 5. There's your first bracket, so first plus second, and then first minus second. So 7 plus the root of 5 minus 7 minus root 5. Don't forget it's getting a bit tight there, but you'll be alright. You'd end up, they would cancel for me. 7 and 7 would be 14. Next bracket, the 7s would cancel for me, plus 2 root 5, and then 14 by 2 is 28 root 5. That would be a nice simple way to do it. A lot of people will miss that one. What most people will do is this. They'll say 7 plus the root of 5 multiplied by 7 plus the root of 5 minus the mistake people make when they're doing this question is they go to multiply in that minus first of all. That's a mistake that people make. And then sometimes, depending, they try and multiply it into the far side as well. Of course, you don't want to be doing that. I'm going to try and rub that out. Seven, 7, so taking the first bracket on the, in that case, what do you actually do? I would multiply out this bracket as is first, and I would just drop the minus down. You're going to see me do that in a moment, and I would just put it all in the bracket. Bracket over here on the left hand side anyway, 7 by 7. 7 sevens are 49. Work it through. So plus 7 root 5 plus 7 root 5, and then root 5 by root 5 is 5. Over here 7 sevens 49 minus 7 root 5 minus 7 root 5, and then a minus by a minus is a plus. Root 5 by root 5 is 5. Tidying stuff up as best you can. So 49 plus 5 is 54 plus 14 root 5 minus 49 and 5 is 54 minus okay, so what are you going to be left with? Let's see. 54 so multiplying that minus in now into both parts. 54's cancel for me. 28 root 5. I take it that you can see the advantage of spotting the difference of two squares. Okay. If you do it the longer way, there's a lot of areas that you could make mistakes. But it's a tricky question, and if you can do that, you can do most things. Okay. That's about as hard of a surd question that you can get, pretty much. So I'm going to have to stop there.